You're viewing the Crate Pro inventory video. If you didn't already do so, be sure to view the Getting Started with Crate Pro 2 of 2 video for some basic information about navigating Crate Pro. The inventory file is primarily intended to maintain your raw materials and is an integral component of design creation in Crate Pro. Unlike most inventory programs, this module is not intended to manage material flow or ordering, but is to provide the design engine with the critical and controlled data to assure fast and accurate designs. To maintain control, your materials are broken into one of 11 types: plywood, lumber, padding, wrapping, hardware, assembly, fasteners, labels, coatings, and other. These are the basic types that are available in the design module, and services is available in the jobs module as well. The inactive tab lists all items that are not currently active. Just like in the contacts file, an item must be active to appear on a selection list. This way, if you add an unusual material for an odd job, you can make it inactive later so it can't be selected when it's not needed. Most material types have their own unique characteristics and need to be separated. For example, you would want to be sure a user doesn't try to use a coating, such as paint, for a cleat. In some cases, the categories are just for clarity and to keep selection lists short. An example here is labels. There's nothing special about them, but the list could get pretty long, and if you don't want to have to rummage through cam locks and bubble wraps, separation is a good idea. We're going to review some of the critical aspects of the inventory file. Keep in mind that the integrity of most of the settings in the file are critical. One of the great benefits of Crate Pro is the time it can save you, in part through accurate and consistent design methodologies. But if you enter a 2x4 as 6.5 inches wide, you just lost that benefit. There are other settings that are even more critical because a mistake in them could cost you $1 or $2 per crate, and if a mistake like that goes unchecked, you could go years without even knowing it. So, let's get started with the Plywood tab. Oh, and this is a good time to say, just like I usually call everything a crate, I do the same thing with plywood. When I refer to plywood in Crate Pro, I mean any type of panel board. There are some fields that are the same for all material types, such as the description, and there are other fields that are often similar, such as the price per something. Let's go ahead and take a look at a particular record here. So, commonly, we have a description, and we have some sort of a cost and a weight factor. Obviously, go to a particular item again, we have the same thing in lumber. We've got a description and a cost and a weight. These fields are common through all of the items. Now, these types of fields I think are pretty self-explanatory, so we're not going to go over those now. We're going to go ahead and discuss fields that are unique to the different types of materials. So, to view an item, select Edit from the desired material at the bottom of the screen. This will make the material appear on the top of the screen where you can view or edit some of the details. We're going to go ahead and select let's go ahead and do a 3/4 inch CDX. Now, one of the first things you're probably going to notice right off is that you're going to want to check the prices in Crate Pro. Although they should be close to your costs at one point in time, times changed and so have the prices. So some of these may be close still, and some of them, especially with the wood materials, could be pretty far off. So make sure you check those before you start. Crate Pro costs plywood by the square foot, so that's what you would need to enter here. Likewise, the weight is also per square foot. Crate Pro uses what we call rules to determine the appropriate spacing for intermediate cleats. Some rules are based on the size of the plywood, so Crate Pro requires the material dimensions. When designing a crate, you can also modify the cost of the crate by adjusting the plywood yield. To do this accurately, you need to know the material size you're working with. So here we've got for plywood, we have the width, obviously, the length, and of course we need to have the thickness as well. To have a material show up on the material section list so that the user can access it to modify a design, you need to make sure that active is checked. Now in some cases, Crate Pro accommodates crates and pallets separately. Odd as it may seem, CratePro designs about 250 different styles of crates, but nearly 1,000 different styles of pallets. And that's in part just because of the way CratePro works and the way CratePro defines pallets. We'll look at the difference between the crate and the pallet fields when we get to the lumber section. So for now, we'll take a look at waste and cut time, only as it pertains to crates. The waste factor is the amount of this particular material that you typically throw away. In this case, this is say that when you use 3/4 inch CDX on a crate, you usually end up throwing away about 15%. Now, as with settings in the rest of CratePro, you adjust this setting to the value that's right for your company, and keep in mind that CratePro has a yield adjustment tool, so you can change this in the design itself when you create it. This value is added to the cost of the material actually used in your design. So in this case, if we have a design that's using 3/4 inch CDX, and let's say the cost of the material that actually goes into the design is $10, CratePro would add $1.50 to that. As a result, your material cost would be $11.50. Now that's your cost. That doesn't have anything to do with profit. Your profit is calculated after the cost is calculated. Now the cut time here is the time that it takes to cut 1 linear foot of this material in minutes. If you're setting up CratePro to work metrically, that time is the time that it takes to cut 1 linear meter per minute. Now, this time may likely look high to you. Don't change it for now till you have a full understanding of how CratePro accounts for cutting time. In CratePro, all the micro steps involved in cutting a piece of material can be broken down into 2 parts. CratePro handles the rest. One part is the time it takes to prepare for a cut, and the second part is the time it takes to make the cut. We won't discuss this here because it's covered in another video in the setup file about how to set up your times. Just understand that this time is very often accurate right when you start with CratePro, and you don't need to change it. When you do change it, the change should be very slight. Okay, let's move on to the lumber tab here. There's a couple of differences between plywood and lumber. So let's start by selecting 1x4s, and we can view the material at the top of the screen. So here's our 1x4, and here's our material at the top. The first thing that you may notice here is that the cost and weights are by linear foot rather than board foot. For us Americans and those around most of the globe, you may be surprised to know that board footage can be calculated in 2 different ways, and a few countries are different. Until some issues are worked out with this, CratePro works best by linear footage. Now that we're on lumber, let's take a look at the difference between crate waste and cut times and pallet waste and cut times. Now, understanding that the pallet industry is very different than the crating industry, and it's very possible to mass produce pallets with machinery, although you may or may not do that, CratePro has to account for waste and cutting time differently. This is a really good example because as a pallet manufacturer, you may very well purchase your 1x4s pre-cut. And in this case then, all of the cost and time of cutting is built into your purchase price, as is waste. So this example shows that if we make a crate with 1x4, we're averaging a 10% waste factor, and we have an average cutting time of 0.08 minutes. Now that's not 8 seconds, that's 0.08 minutes per cut of 1x4. Now again, this example, we're showing that our waste factor for pallets in 1x4s is 0, as is the cut time. So this would assume that we're buying our material pre-cut. If we didn't buy our pallet material pre-cut or our 1x4s pre-cut, then we would have a waste factor here and a cut time for pallets. Or if you don't manufacture production pallets, if you make them by hand, then you may want to match these values here, or at least match the cut time. That's probably the same. Your waste factor may be different, and you may want to account for that separately. Now, if you do have a situation where, for pallets as an example, you sometimes purchase your materials pre-cut and sometimes you don't, keep in mind that you could add 2 different occurrences of 1x4 in your inventory. In this case, our 1x4 is named just that, 1x4. You could add another material to inventory that's called, let's say, 1x4x40, in which case you're indicating that that's your pre-cut material. Have that in inventory, and then when you do have pre-cut material, you'll select that from the inventory rather than the standard 1x4. The lumber material has a couple of new fields that the plywood didn't have, and that's our fastener rows, through thickness, and through width. Now these fields allow CratePro to calculate a reasonable and consistent number of fasteners at lumber junctions. What's that mean? Well, although these values are used in CratePro, it can best describe them in the context of pallets. In most cases, CratePro designs performance pallets and containers rather than engineered. In this case, that means CratePro will not tell you what the weight capacity is of a given pallet design. Likewise, it won't identify that you should use a ring shank nail versus a straight shank. What it will do is suggest to you how many fasteners to use at each junction where a stringer meets a deck board. This quantity of fasteners is determined by the surface area of that junction. After CratePro makes it its reasonable and consistent recommendation, you can change the quantity and type of fasteners you see fit. In this case, it'll simply provide you with a starting point. Now, this is a good time to step away from the specific features of CratePro for a second and present some of the economic benefits of the program. CratePro can be precisely accurate, or it can be very accurate, and there's benefit to each of these. Some CratePro owners tune CratePro to the penny, while others don't. This isn't so much a matter of how much time you spend setting it up as it is a matter of management philosophy. With CratePro, you can have a high-valued engineer and charge more for your services, or you can have a low-cost office clerk develop the designs for you and charge less. The real benefit from CratePro is that you can do both. Listen on. CratePro will allow you to set up controls and define company policies to allow general office staff to generate very close quotes. With your good customers, you may have an agreement that a fast quote is plus or minus 10% if not reviewed by an engineer. For smaller customers, you use a different quote form and set up the customer so that there's a little extra cushion in the pricing just in case. You can set up CratePro so the pricing is typically a little higher for small customers and a little lower for larger ones. When a larger customer wants a more accurate quote, or when a larger order comes in, you can have the engineer fine-tune the design and provide an exact quote. This is just one of the many ways you can use CratePro to optimize your staff and increase profits. Okay, back to the program. Let's move on to padding. In most people's minds, padding and wrapping are similar, but to CratePro there is a difference. To express it in the simplest way, padding is used on a single surface of the content, while wrapping is intended for multiple surfaces. Now, this is a general and not totally accurate statement, so let me refine it a bit. Anything that is typically measured based on the surface area of the panel is padding, while materials that are measured based on the inner surface area of the crate or the surface area of the content is wrapping. Now that's still a little general. Two examples of oddities to this are loose fill and case line paper. Since loose fill can be applied in a set number of inches to each separate panel of a crate, it is a padding just like sheet foam would be used as a padding. Another consideration is that padding typically has a significant thickness. Case line, however, does not have a significant thickness and can be considered to be applied in a wrapping fashion, even though that wrapping fashion is often in rectangular sections. So here we can see in padding we have loose fill, and in this case we've designated the loose fill to be, let me see, what was it here? 2 inches thick. Now, we have a cut time. Now in this case that's not really a cut time, it's a little bit of a misnomer, but for loose fill that's to say that it's going to take about 1/4 of a minute to install or insert or drop in 12 inches by 12 inches by 3 inches of loose fill. Now we've got to keep in mind that our time here is more than just the time it takes to to put the loose fill in the box, but it's the time to prepare for it and all of the overhead that goes along with it. And you can see everything else in here is actually a sheet foam. Wrapping. See, we have typical wrapping materials. We have bubble, case line, cellulose wadding, felt, barrier materials, etc. Okay, let's take a look at hardware. Now, hardware is a type that exists solely for the purpose of separation and rapid identification. This is not to be confused with fasteners. While fasteners may be a type of hardware, the hardware type listed here is generally for all hardware other than fasteners. Assemblies can be used for groups of materials such as nuts and bolts when they're put together in a set and when they're not used as a fastener. Now, I'll explain the fastener thing a little bit more shortly. It can also be used for non-tangible items such as vent holes and stenciling. The core design engine of CratePro doesn't directly accommodate features such as vent holes, but by adding them to the inventory file here, you can incorporate them into the design as a miscellaneous item. This way, their cost, weight, or in this case the reduction of weight and time to make the hole can all be accounted for. First, in talking about fasteners, it's important to point out the accuracy of CratePro. As you can see, even fasteners have a cost, weight, and installation time to them. To make a point of the accuracy of CratePro's design and costing, if you change one cleat on a crate from a 1x4 to a 1x6, the cost, weight, and time to install the fasteners will all be increased accordingly. No estimating is required. Now, this part about fasteners that we're about to go over can get a little bit confusing, but keep in mind that all of this is already set up for you. What you're looking at here with the materials in CratePro is the way CratePro comes, and all of the values, all of the data is already entered. Fasteners are a separate type because they're an important part of the design. Fasteners are anything that can be used to attach one major component to another. In this case, major components are panel boards, plywood, cleats, skids, etc., or to attach one panel to another. CratePro has a unique feature that identifies when different fasteners are used to attach panels to each other. Let's take a look at the diagrams here. Okay, now we're going to take, for example, a PPPB 26195 box, what we're looking at here. Or in this case, it's an MPO 001 in CratePro. Now, the 5 cap panels may be nailed together. You don't see here typical nailing around all of the edges, while the cap as a whole may be lagged to the base. CratePro will account for the 2 different types of fasteners and the spacing between them. In CratePro, this is what we call closure condition. Go up to closure and take a look here. Now, here are some different types of closure conditions. We've got setup. In this case, we'd have the same type of fastener all the way around. Let's take a look at top off, or TO. So in this case, we'd have possibly a different type of fastener around the top of the crate. So all of this may be nailed together, and then the top may be nailed. Could be put together with climp locks, or climps I should say, or cam locks, or some other kind of alternate fastener. Now, as you may expect, when you use different fasteners in these different areas, they may be spaced differently as well. So in the setup file, there's a setting to indicate how far apart fasteners are placed in different situations. By situations, I mean situations like stitching a cleat to the plywood versus attaching one panel to another. The values in the setup file provide a baseline for the calculation that determines fastener spacing. Any fastener that would deviate from that baseline will have a factor of more than or less than 1, while fasteners that don't deviate will have a factor of 1. Let's look at this a little bit closer. When used to assemble the 5 panels on a PPP B601, right now we're going to look at the 5 panels and we're going to call the base a panel here. We have a base panel in this case. You would typically place these fasteners on average about 4 inches apart. Now I say 4 inches, I'm rounding here. You may place them a little bit closer, you may place them a little farther. You may place those 4 inches apart. So you'd have nails every 4 inches there, nails every 4 inches there, nails every 4 inches there. When you put this cap on with an alternate fastener, or let's go ahead and go back here, take a look at this again, and in this case where we put the cap on, and we would be using an alternate fastener across the bottom, in this case a lag bolt, and let's say that we would place those lag bolts 12 inches apart. If this were the case, we'll still say 4 inches up and down here, then our nails here would have a factor of 1, because in the setup file we say we place these 4 inches apart. The nail we actually place 4 inches apart, so we have a value of 4 times a factor of 1 equals 4, which means there's a nail every 4 inches. Now that's probably not so important, but then when we get down here this gets more important because we have more valuable fasteners. The lag bolts are more expensive than the nails probably, and other fasteners can get a lot more expensive as well. If we're going to say here that we have fastener spacing of 12 inches, and this is part of the entire cap, well, our spacing value in the setup file is 4, and if we want these to be 12 inches apart, we need to put a factor in the inventory for these of 3, in which case 4 times a factor of 3 equals 12, and the result is Crate Pro will put a fastener every 12 inches. Let's go back to the inventory file, go back to the fasteners, and let's take a look at, we'll just grab one lag bolt here, and we can see a fastener spacing of 3. I hope I said that right earlier, times 4, which is in setup file, so that puts those every 12 inches apart. And then for most of our nails here, take a look at this one, a 2 1/4, and we have a spacing factor of 1. So you can see how all that comes together. Now, don't worry if that's not what you would want. Again, you can change the settings in Crate Pro. This is only a suggestion. We're only giving an example here. Now, as I mentioned earlier, some of the material types here are only to separate those materials and make them easier to find. That's the case with the rest of the types of materials, except for services. Services are only available from the jobs file, so you can't add a service to a design. Use it for things like trucks or rigging or other similar items that don't actually become a part of a crate. These are items that shouldn't modify the cost of the container, but will change the cost of a job as whole. Alright, let's take a look at the Inactive tab. Under the Inactive tab, you'll find items that are in the inventory file but are not checked as active. When designing a crate, you can select from an active item in the inventory, but if a material is listed as part of a material group, or if you copy an existing design, Crate Pro will use the required materials even if they are not active. For this reason, Crate Pro needs a consistent reference to any material that's ever been used in the program. For the same reason, anytime you delete a material, you must redirect any existing references from that old material to a new material. Let me give you 2 examples of why this is important and how it works. Let's say you have 2 different 1/2-inch plywood items in inventory. One of them is a 5-ply and the other is a 3-ply. And let's say you used to get a great deal on the 5-ply and you used it for all your plywood bases on light-duty crates. Now, things have changed and the price of 5-ply isn't as good as it used to be, so you've decided to change permanently to using only 3-ply. Because you used the 5-ply on a regular basis, you had it as part of your material group for light-duty crates. If you remember back to one of the first videos, we talked about material groups in the setup file. Also, you have a history of hundreds of designs in the crate file that use this material. Now, if you were able to simply delete the 1/2-inch 5-ply and forget to replace it with a different material in the material group, every light-duty design with a plywood base that you would design from here on out would end up without a base. This is simply because the material no longer exists for CratePro to use. Now for the second example, assume you have an old design that uses the 1/2" 5-ply and the customer places a new order for the same crate. In this case, you would make a copy of the existing design record, then select the option to update the times and prices from the inventory file. When you do this, CratePro is going to look for that 1/2" 5-ply in the inventory and not find it. The result in this case is probably worse than in the first example. Here, the 5-ply material would still be there, but the cost would be $0 and the time to cut and install the ply would be 0 as well. So, you may think everything is okay when you look at the cutting instructions, but you take a closer look, you'd realize that you could be taking a big loss on the crate. Although CratePro allows you to delete an inventory material by identifying a replacement for it, oftentimes this isn't a great idea either. This feature is best used only if you're replacing materials of the same dimension. Let me give you an example of how you can override this concern. If we go to plywood here, and let's say, well, what was the example I used? Let's go to a 1/2" 5-ply. I think we have only 1/2" 5-ply in here, and we want to delete it. CratePro is going to say, before deleting this item, we must verify that it's not used as a default material. So what it wants is, it's telling you the item that you're going to delete, but it's going to make you enter a replacement item. And if we do that, then it's going to go through the setup file, and it's going to go through all of your existing designs and see if this item exists, and if it does, it's going to replace it with that one. The last thing we're going to look at in the inventory file is the Fast Edit feature. Now this gives us a table view of our inventory where we can go in and much more rapidly go ahead and update our prices or any other information as we need to. So understanding that the price of wood materials move rather quickly, this gives us the chance to make those changes a little bit more easily than having to go to each item individually in the regular screens. Now, because of the presentation software here, where the side of our screen is cut off a little bit, but we can sort our materials in a categorical order and group them by the type of material. And that makes data entry a little bit faster. Now, that covers the basics of the inventory file. The next video in the training set will cover the diagrams file and the benefits it provides. We'll see you there.